Welcome to Principles for Managing and Controlling a Containment System in Containment Fundamentals. When designing a facility, take the following into consideration: HVAC design, pressure cascades, and traffic flows, both in and out of, people, product, equipment, and waste. Also be sure to take architectural design into account. This example shows a variety of pressure differentials between various spaces of a production facility. The differences in positive pressures show in the form of 1, 2, or 3 plus signs are used to control the direction of airflow. Notice how the red arrows highlight the direction of airflow based on the difference between spaces. For example, the airlock into the processing area is more positive than both the corridor and the area outside of the processing area. In addition to airflow, you must take the flow of people, materials, and equipment into consideration. The entrance and exit of people, materials, equipment, and waste may not be the same, so you need to evaluate your process and determine the best design to accommodate each of these needs, depending on space, process, and philosophy. This drawing illustrates the routing associated with material and personnel flow paths in a process area. Notice that the material routing is different from personnel routing. In general, it is highly desirable, though not absolutely required, to segregate these flow paths to the extent feasible. Architectural design is based on the risk to product quality. When designing, be sure to consider the architectural construction materials and finishes. Also, keep the list of do's in mind. These are 6 examples of containment control devices that will be introduced in this lesson. The Rapid Transfer Port, or RTP, provides a contained system for opening and closing a container or device. This technique utilizes a double-door transfer port design, or DPTE. It is similar in concept to a split butterfly valve, but different in design and use. There are 2 assemblies, alpha and beta, which are color-coded in the diagram. In this design, there are 2 seals meeting at a point. At this point, 4 elements, mutually shielding each other's faces, are locked together by the rotation of the beta's part. Using an RTP is a 3-step process. First, put the container in position. Then, lock by a 60-degree rotation. Finally, open the double door. There are a number of split butterfly valve, or SBV, manufacturers who provide high-quality components. The GEA buck valve is just one example of these manufacturers and is shown here to demonstrate the operation of the SBV system. The first set of drawings shows the position of the active and inactive portions of the valve prior to docking the 2 together. There are 2 views shown of the same operation, one facing outward and the second one rotated 90 degrees. The second sequence of drawings shows how the 2 portions of the valve, active and inactive, are joined and then secured in position. Once the 2 portions of the valve are secured in position, the valve can be operated. The paddle of the butterfly valve now is a single joined component and operates similar to any other butterfly valve, the exception being how these 2 components are joined together and then separated.